Welcome viewers. In this video, we look at how Big Switch enables rich and integrated analytics for big cloud fabric deployments. Unlike disparate box-by-box data collection with CLI, SNMP, or show commands, Big Cloud Fabric now provides integrated analytics to offer contextual visibility and security monitoring necessary for the modern data center. Let us look at the challenges today's data center networks face and see how analytics integrated with BCF solves these challenges. For the most optimized use of network resources, analytics identifies the traffic trends by enabling network-wide monitoring both in real time and historical, and for any host-to-host communication, be it physical or virtual. Security risk identification and event monitoring are achieved by leveraging machine learning to automatically detect unauthorized hosts or services, or for that matter, detect any other anomaly in the network. Many DevOps tasks like application migration, asset management, or identifying performance slowdowns need a clear understanding of interactions between applications. Application dependency mapping helps visualize these complex application dependencies and eliminates the blind spots in the network. And lastly, analytics enables pervasive traffic analysis using a scale-out and resilient architecture that can keep up with the needs of your data center network. Big Cloud Fabric is a leaf-spine fabric built with open networking switches and acts like a single logical switch controlled by the BCF controller. BCF automates networking for multiple private cloud platforms and now integrates analytics to provide visibility for every host in the network. Big Switch Analytics not only collects flow records but also processes metadata generated by BCF such as ARP, DHCP, and ICMP traffic, thus enabling the network admins to operate networks more optimally and securely. Let us now take a look at how analytics uses these traffic records and metadata to identify and troubleshoot issues in the network. The first one is, how do I find the top talkers in my network? This visualization has the inner ring corresponding to the source IP addresses of the collected flows. The outer ring corresponds to the destination IP address that this source is talking to. These IP addresses are sorted based on the volume of their traffic, giving you the top talkers in your network. Let us take a look at the next use case. What are the top protocols being utilized in the network? This visualization lists the protocols used. These are sorted by their traffic volumes, and in this case, it is easy to see that the top 3 protocols are HTTPS, OpenVPN, and SNMP. What are the top apps being accessed in the network? This visualization shows us the top applications being accessed in the network. Here, GitHub is the most popular app, followed by Google Apps. Now let us look at some security use cases. One question that security admin is concerned with is, are there any unauthorized hosts in the network? This visualization on the ARP dashboard tracks the devices that newly joined the network. In this case, a Nutanix cluster has joined the network. If this cluster was not authorized by DevOps, analytics can make a REST API call to the BCF controller to block the endpoint. As we can see here on the BCF endpoint page, the Nutanix cluster has now been shut down and disconnected from the network. Another security concern is that how can I identify a rogue DHCP server in the network? A rogue DHCP server can hijack the clients and cause phishing attacks. All you have to do is configure the DHCP dashboard with the list of authorized servers, and this visualization will identify the rogue servers for you. Additionally, you can get alerts on Slack or via email in case a rogue DHCP server is detected. Another task where analytics can help the network admin is fingerprinting client or server operating systems in the network. This visualization does the OS fingerprinting and helps identify unsupported, obsolete, or vulnerable operating systems such as Windows XP. Now, from the network infrastructure point of view, how do I get a view of an application's dependency on other applications? If I need to upgrade an application, which other apps might get impacted? This is answered by Graphs dashboard in Analytics. It draws a dependency map across the applications. The network admin can now quickly find the impact of upgrading a particular application. Now on to the last use case. When there is a DOS attack, can the network admin be automatically alerted? Using machine learning, analytics can establish a baseline of normal traffic patterns. This baseline can distinguish between a surge in traffic, perhaps due to a large online shopping event, and a DOS attack. In the case of a DOS attack, the traffic pattern deviates from this baseline, and machine learning identifies this as an anomaly. The admin is immediately alerted with the details of the anomaly. To conclude, we saw how analytics is an essential component of the big cloud fabric and can establish traffic trends, identify security risks, map all the application interdependencies, and use machine learning to automatically alert on detecting anomalies. This helps the operator of the data center to develop a deep understanding of the network and make smarter, data-driven decisions. Thank you for watching. For more information, please visit us at labs.bigswitch.com.